So this is beginning to talk about the induced voltage. Here's our, if they rewrite it, here's our function of time. There's the peak. Omega is 2 pi f. The peak value is the WMBA. On we go. And here's a little example with a generator. It's pretty nice. In general, all we're going to do is that the peak voltage is the WMBA kind of thing, and then use that to solve for one missing piece. That's almost always what that is. Here you see the sinusoidal voltage symbol, graph. And in this one, it was actually 21, not 22. Here again, we see that formula for the voltage out of the generator. Here we're finding the current is this maximum out divided by the resistance gives me the I max that they didn't label. Here's our sinusoidal voltage. Here's our little circuit diagram. Here they tell you that omega is 2 pi f, always good stuff. Here's where they talk about the powers, the current times the voltage, and you get that IV sine squared kind of graph. I squared R, V squared over R for the amplitude of the power function. So then the average is half of that. And so here's where they're trying to find the average, cutting it in half, filling in the gaps and holes kind of things. Here they call it a DC average, which is our RMS average. And so this, the peak value over the square root of 2 is what that turns out to be. So peak over root 2. And then here's some examples. And so let's do our examples.